Okay, thanks Lindsay for kicking us off. Let's see if I can, already went too far. So good morning everyone, nice to see so many faces. If you want to come and sit down, there still are seats at the front. I'm happy to have you come join us. For those that don't know me, my name is Emily Cranston. I'm an associate professor in both wood science and chemical and biological engineering. And it's my great pleasure to get to give an overview about theme 2, which is bio-based nanoparticle-enabled materials. And so the theme has about 14 members spanning many different departments and faculties. And really what we're aiming to do in this area is to study these bio-based nanoparticles to better understand their self-assembly, to understand how particles interact with each other or with their environment and other components, and to build up enabled materials that might be what we call hybrid materials containing both bio-based nanoparticles as well as polymers or other synthetic nanoparticles. And as you can see on the screen, we imagine a really large range of applications for these kinds of materials, spanning from high volume but sort of low value applications, maybe things like in pulp and paper and packaging products, some plastics replacements, but then moving into applications in the built environment and in construction, in energy production and storage, moving into electronics, maybe things like wearable textiles, smart textiles, and then at the very high value end, we're talking about biomedical devices. So this could be tissue engineering or implantable materials or devices for diagnostics. And so I'll start out by talking about myself. I know that seems a little self-centered, but it's just in alphabetical order. So in my group, as I mentioned, wood science and chemical and biological engineering, we're the sustainable nanobiocomposites group. And a few things that I wanted to highlight from our lab is that we are working with a huge number of researchers across the BPI. And I just want to say that I feel really lucky to have worked with so many people that are listed here. Even the Marks got combined onto one line, both Mark McLaughlin and Mark Martinez, because I was running out of space. But these people have been incredibly generous with both their time and sharing equipment with me and my students. So that's been really great to push our research forward. We have a number of new industrial partners as well. And I also have taken on a role as a senior editor for the ACS journal Langmuir, so I encourage people to send your papers to us. In terms of highlighting some new research in my group, we recently published a paper where we developed a quantitative spectroscopic method to analyze nanocellulose. And so this is based on the natural fluorescence that cellulose has, and it allows us with one data set to measure the concentration of nanocellulose, the surface charge density, and the onset of liquid crystalline phase separation or gelation. So I think this is really moving characterization forward in the area of bio-based nanomaterials. We've also published a review on all the different ways that you can make cellulose nanocrystals and the different starting materials, and that's in Nature Reviews Materials. Next we have sorry, the slides are a little delayed, and if I click too fast, I lose it. So next we have Professor Johan Foster in Chemical and Biological Engineering. He runs the Foster Advanced Materials Group. Johan has had a great year, and I highlight that at the Canadian Chemical Engineering Conference held earlier this fall, a bunch of his students won poster awards and presentation awards, so that's been very exciting for their group, as well as recent coverage in the media through Globe and Mail. An example of some research in Johan's group is looking at, sorry. So the example shown on the right here is a new fluorometric technique. So again, we're focused a bit on characterization of materials, but this is the first report using fluorimetry as a way to understand lignin degradation in fiber cement materials. Next, we have John Frostad in Chemical Engineering and Food Science. John's group looks at interfacial phenomena, and on his website, he has some really nice images that are shown there. He has a bit of an image competition, so I encourage you to check out his website for beautiful photos of interfacial phenomena. And in John's group, they've recently published, in collaboration with BC Research, the ability to use aqueous gels, so oil wicking aqueous gels, to clean up oil spills and the effect of surfactants. So some really important interfacial phenomena to be studied there. I'm starting to get the hang of the clicker. Next in our group, we have Professor Dana Grekov in mechanical engineering. Dana runs the Industrial and Biological Multiphysics Laboratory. We've been working with her as well. And just to look at two really exciting research highlights in her group, they were the first last year to show that sonication could be used to control the lubrication performance of nano lubricants. And so if you see point D that's highlighted on the graph, they had this minimum that if you put the right amount of energy into the lubricants that were based on cellulose nanocrystals, they could minimize the wear and minimize the coefficient of friction through this optimization of the ultrasonication. So some of the first nano lubricant developments. Along the same theme of nanolubricants and tribology, they've combined cellulose nanocrystals with hyaluronic acid to show that this is a potential viscosupplement or a treatment for osteoarthritis. And this is ongoing work in her group. Next, we have Professor Feng Zhang in wood science. He runs the Sustainable Functional Biomaterials group. Feng has recently, as Orlando mentioned, had a lot of coverage in the media. I think like over 100 news outlets that have picked up on some of his newest work related to bio-based foams and bio-based packaging films to replace plastics. And so one example is shown here. So these are scalable, hydrophobic, and mechanically stable foams that can be used for packaging and thermal insulation. And this work was developed in collaboration with the Wet'suwet'en First Nations. Next, we have Hongbin Lee in chemistry. He runs the protein-based biomaterials group. And I want to say a huge shout out to Hongbin because this year he started to lead a new NSERC Create grant, which is a huge undertaking with $1.6 million of funding to come in for a training network related to 3D printing technology and materials, some of it focused on proteins. And I added the photo in the bottom there of a 3D printer with a Christmas ornament, thinking that maybe if Hongbin has a bit of free time, he can print us some interesting new decorations for our tree using proteins and other bio-based materials. One example of research to highlight in Hongbin's group is a new paper in Nature Communications where they've developed shape memory and morphine hydrogels that are based on protein folding and unfolding. So really interesting how we can actuate and control materials based on natural tendencies. Next, we have Mark McLaughlin, also in chemistry. He runs the Supermolecular Materials group. We've been working together on the thermal stability of nanocellulose. Mark has just had his Tier 1 Canada Research Chair in Supermolecular Materials renewed. And a highlight from his group is shape memory photonic thermoplastic materials. So what this means is he has nanocellulose embedded in plastics, and when you press them different amounts, you get different colors. So you can do imprinting to get different patterns, but when you heat it up, it goes back to its original color and you can print it. So you can do this over and over again to produce materials that might be used as temperature indicators or as recyclable and reusable photonic materials. Again, really showing the breadth of research that goes on within the theme. Next, we have Professor Adriana Manso, who's in dentistry. She runs Restorative Dentistry and Dental Biomaterials Group. And another congratulations to Adriana for being awarded one of these research excellence clusters that are given out by UBC's VPRI. And so she has just started this excellent research cluster in advancing multifunctional dental biomaterials. And within that framework, we have a new PhD student, Ariana Fernandez, who is going to be working on nanocellulose in dental varnishes and emulsions to reduce tooth decay. The next person needs no introduction, but we have, of course, Professor Orlando Rojas. And for those that don't know, he's joint between chemistry, chemical and biological engineering and wood science, and is the director of the BPI, so he wears many hats and has a very large research group here as well. He is one of the most cited scientists in the world over all time, so this is bringing a lot of recognition to us here at UBC and to his work. His research spans many different areas that fit within probably all of the themes here at the BPI, but just looking at theme 2, again, bio-based nanoparticles and the materials they enable, Orlando has shown some new publications in water and dry processing, in surface modification, in the self-assembly of these nanomaterials, in utilization of food waste and other forest residue products. And then at the bottom there, using nanobioparticles in 3D printing, biosensing, and photonic materials. And last but not least, we have Si-Yun Wang in food science. She runs a food safety engineering group, is collaborating with a number of other people within the BPI. And the research highlight from her group is the development or the discovery of new bacteriophage that can inactivate E. coli. And so this is going to be really important to support the development of new biocontrol products to tackle food safety issues. So I hope that gives you an idea of the breadth of the work being done in theme 2. I can just put up a slide to show as well that we have a bunch of new tools, some really interesting equipment for measuring very precisely at the nanoscale or more macroscopic absorption, permeability for packaging testing. We have new gas and vapor permeability equipment, conditioning chambers, and lots of equipment for preparing materials, dip coating, spin coating, spray drying, bar coating, foam forming, and some of the equipment that's shown here on the slide, which is available to the researchers within the BPI. Some upcoming tools in terms of new spectroscopy and hopefully, fingers crossed, for grants in for new tribometers and new rheometers coming this year as well. And just one last thing to mention here on the right is Carl Michael in physics is developing a new phosphorus and proton probe for the NMR in order for us to be able to do some never before done experiments on studying proteins like myelin that are really important in spinal cord regeneration. So lots of equipment, lots of people, and very exciting research. And I just put up a few snapshots here of the media coverage over the last few months for the researchers that are within theme 2. So a huge congratulations to everyone for a very productive 2 years. And of course, it's wonderful to be here together again. So thanks very much for your attention.